In this video, we're going to be starting section 1.6, which is covering the topic of inverse functions. As a warm-up, we're going to go through this example. You have a function that takes a number, multiplies it by 2, then subtracts 7, and lastly, divides by 6 to get the result or the output. Describe using words a function that would take the result of the described function and returns the original number. So, if I take a number, let's call it x, and multiply it by 2, then subtract 7, and then divide by 6, I'm going to get some number. So, what would I have to do to undo those operations? What order would it have to take, and what would the specific steps be? So, if I have an answer, we would do this in the opposite order. So the last thing I did was divide a number by 6, right? So divides by 6. So the first thing I would want to do is undo that, so I would have to multiply by 6. Multiply the number by 6. And let's move backwards. I multiplied it by 2, then subtract 7, lastly. Okay, so the step before dividing by 6, I subtracted a 7. So I'm going to add the 7 back in. Then the first thing I did was multiply by 2. So if I want to undo that, I'm going to divide by 2. Let's make sure I got it all. You have a function that takes a number, doubles it, subtracts 7, divides by 6. And so now what I'm saying is if we want to undo the opposite of that, let's use x as the same number. So I'm saying we're going to do 6x plus 7 divided by 2, and that should give me the number. So in theory, if I've done this correctly, we're going to pick a number for x here on the first one. We're going to see what we get for an answer. So let's see. It doesn't really matter, I guess. Let's pick 1. 1 times 2 is 2. 2 minus 7 is negative 5. Negative 5 divided by 6 is negative 5/6. If I now take negative 5/6 and I plug it into here, if we've done this correctly, it'll undo all the steps that what we did to the number, and it'll give us what we started with, which I believe was 1. So let's give it a shot. Negative 5/6 times 6. I'm going to just write it down. The 6's cancel. I get negative 5 plus 7 is 2. 2 divided by 2 is 1. So in this function, I started with 1, and it gave me an output of negative 5/6. In this problem, I started with negative 5/6, and it gave me the answer of 1. So that's not proof, of course. That's just one example, but it shows you what we're going to be talking about today. A function is just a step of, a set of operations that are being done to a number. And so if you want to undo those steps, we need to have some way of doing that. And that is what an inverse does. All right. And by the way, what we just did was called basically finding the inverse informally. All right. The inverse of a function, f, which is denoted by this statement, f to the negative 1 power, is a function that undoes function f. If the domain of f is the set A and the range is the set B, okay, so we've got a domain and we've got a range, then the inverse, if we use the same B, the outputs from from the first function, if we use those as our inputs, it should return the values we started with, as we just saw in our example. We plugged in 1, we spit out a negative 5/6. So we went from a number in A to a number in set B. Then I took the number in B and plugged it into what I thought was the inverse, and it spit out A. And that's what an inverse does, and that's what this is describing. In other words, the domain and range of inverses are swapped. All right. You can verify that two functions are inverses of each other by doing compositions. So if f of g of x and g of f of x equal x, then we know that this is a function. And let's look at that using our little function machine example from the last section on compositions. So if this is function f of x, and I plug in x values, and y values will come out. And if they drop into something that we think is the inverse of f, then this machine right here should automatically take these outputs, should undo all the operations we just did to them, and it should spit out what we started with. It should spit out the original information. If it doesn't spit out what you started with, then this is not a machine that undoes the first machine, and therefore it's not an inverse. Okay? So it would make sense that we plug in x and we get x as an output, and that's what this is saying. All right. Last note on this before we start doing some math is please don't be confused by the notation f to the negative 1 of x. It does not mean the reciprocal. Okay? We learned and we know that 5 to the negative 1 is equal to 1/5. We know that this negative 1 power means reciprocal. But in reality, what it means is inverse. And it just so happens the inverse of a multiplication is division. And so the reason we sort of shorthand and call this the reciprocal is because the inverse of multiplying by 5 is multiplying by 1/5. So for one function, the function x, if I said f of x equals negative x, the inverse of this function would in fact be 1 over x. Okay, because those are inverse operations. But don't be confused. In general, raising something to the negative 1 power, a function like this notation, doesn't mean reciprocal. It means inverse. Okay? We just shorthand it for numbers because the inverse of a number is its reciprocal. All right. Hopefully that made sense. I'm trying to rush through this so it's not a super long video. All right. Example 1. Let's repeat what we did in the warm-up. Find the inverse informally. Verify you found the correct inverse. So this is saying I'm going to take some number and multiply it by 4. And so if I want to find the inverse of that, I would take some number and divide it by 4. All right. So if I do f of negative 1 of x, and I do the reverse, and they both simplify out to be x, then yes, I have inverses. All right, so what does this say? This says take function f, 4 times x, and we're going to replace x with the other function, x over 4. When I multiply, the 4's cancel and I get x. If I do it the other way, and I take what I think is the inverse, which is x over 4, and I plug in f of x, 4's cancel, I get x. So yes, we have verified that x divided by 4 is the inverse function to 4 times x. All right. So that's great, but we need a way to do it as the problem gets more complicated. And so what we do is come back to this statement that we just quickly discussed right here, that inverse functions are just ones that have your domain and range swapped. Here it is here in red. The domain and range of inverses are swapped. The domain of f must be equal to the range of the inverse, and the range of f must be equal to the domain of the inverse. X and y get swapped. Which means if we want to find these algebraically, then all we have to do, I'm doing something I shouldn't be doing. My apologies. I'm answering a question for the future. This just said verify. I did not really think about what this said. Okay, so all they want us to do here is to do f of g of x and g of f of x and find out if they are inverses. So if they are inverses, when I do the composition, 2x cubed minus 1, and this is the cube root of x plus 1 over 2. We're cubing a cube root, so that just cancels out, and I get simply x plus 1 over 2 minus 1. My 2's will cancel, giving me x plus 1 minus 1, which equals x. So f of g of x equals x. So that is a good indication, but it's not proof until we show it the other way as well. So I'm going to also approach this one. Equals the cube root of 2x cubed minus 1 plus 1 over 2. All right, so I just stuck f of x in for this x. And we clean it up. My 1's cancel. My 2's cancel. And the cube root cancels out the cube, and I'm left with x. So yes, these two functions, f and g, are inverses of each other. One undoes the other. All right, example 3. Graph f and its inverse on the same plane. Hint, swap the domain and range to find the inverse. All right, so what's implied here, even if it's not stated directly, is let's graph the function, because we should be able to graph that pretty easy. It has been shifted up 1, and then our pattern up 1 over 1. 1, 2, 3, 4, 5, 6, 7 more for a total of 8. Down 1, 1, 2, 3, 4, 5, 6, 7 for a total of 8. All right, so there is my graph. All right, so if you ever want to graph an inverse, we're going to do exactly what inverses do, which is what I started to talk about in the last problem, is that the domain and the range get flipped, literally. So all I have to do is identify the points on my original function. So for example, we have this point here, which is 0, 1. We have 1, 2. We have this point here, which is 2, and what's that going to be? Moved it up 1, so that should be 2, 9, I believe. This is negative 1, 0. And this point down here would be down 7, so it's going to be negative 2, negative 7. All right, so if I want to graph the inverse, all I have to do is swap the domain and range. I have to swap the x and y. So 0, 1 becomes 1, 0. 1, 2 becomes 2, 1. 2, 9 becomes 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 2. Negative 1, 0 is 0, negative 1. And this will be 1, 2, 3, 4, 5, 6, 7, negative 2. The pivot point is going to translate to this one. So here's where my graph kind of changes what it's doing. And I get that graph right there. So this is the inverse. And this, of course, is the original. Okay, a couple things to notice. When you do this, this is just a reflection over the line y equals x. If I were to draw a perpendicular line from a function and its inverse corresponding point, we would see that it is simply a reflection over that line. Same distance here, measured along a perpendicular. All right, so we could also now, based on the graph, what's the equation of the inverse? We see it's a cubic function. I'm sorry, a cube root function that's been shifted over 1, and that's it. And so I would say that the inverse function, based solely on the picture, is going to be the cube root of x minus 1. All right. And of course, we could verify we did it correct by doing the composition, but I feel pretty good about it. All right. And finally, this is what I was starting to talk about earlier. We're going to do what we just did. When we graph those functions, we just swapped x and y. So if we want to find the inverse function algebraically and formally versus informally, all we're going to do is we're going to take the given function. I'm going to rewrite it with a y instead of an f of x. And then I am just going to swap the x and the y. So that's going to give me x equals 5 minus 3 y. Okay? So my x and y literally just swap places. Now, technically, that is it. Like, that is the inverse, because I did what an inverse does. I swapped the x and the y. However, we don't usually leave our equations as x equals. We usually do them as y equals. So let's go ahead and simplify this out to be y equals. So I multiply both sides by 2, and I subtract 5. And I divide by negative 3 or multiply by negative 1/3. If you want to, it's good practice. This isn't very simplified here, but this negative's hanging out here. So instead, what we could do, right, because this negative is on the 3, but you could also, how do I say this? Well, we could do it this way. If we factor a negative 1 out of the numerator, I would get negative 2x plus 5 over a negative 3, right? But I factored out a negative 1. Check it, put it back in, positive and negative. Yep, looks good. And now that negative 1 can cancel out that negative. So in this problem, now let me be clear, if this has been a test, I would have accepted this. But to better ourselves, we should really shoot for exceptional. And so my answer would be, and I like my y over here, would be 5 minus 2x over 3. Normally, if we can avoid it, we don't have the leading coefficient be negative, so I just swapped the constant to be first. Again, that's a little overkill, but technically this would be a better answer than the one above it. Now, the only thing left to do is let's go ahead and rename what this is, which is the inverse of f. So let's go ahead and change the y and name it as the inverse. All right, but don't get caught up in the formality of this part at the bottom. All you do is you swap x and y and solve for y. Okay, so this would have been a fine answer, which you hopefully would have rewritten as after the negative 1 of x. Okay, that's the end of part 1. We'll see you on the next one.